Question 3. Hot water at temperature T. So that's the temperature of the hot water. Temperature T is added to twice that amount of water. That amount of water. Which water? This particular water that is hot. We add hot water is added to twice this amount of water. So the original water, the size, hot water is added to it, to twice of the original water. Go on. It says at a temperature of 30 degrees Celsius. At a temperature of 30 degrees Celsius. Question. If the resulting temperature of the mixture, so if mixture is 50 degrees Celsius, if mixture is 50 degrees Celsius, I'm trying to write the question and read it so it will go resonate over your head. Then you can pause the video and try to solve it before I go on to solve. Calculate T. What is the T? The temperature T there. Let's work this out. Hot water and another water, which will be cold, because you say hot water is at a particular temperature. We don't know the temperature, but we know it's hot. You add it to twice that amount of water. The size of the water before, you add it to twice of that size at the temperature of 30. 30 degrees cold. Then when you mix them, you get 50, which means hot. So let's say this is hot, this is cold. Hot will lose temperature. Its own temperature here is what? T. The temperature of the cold is what? Temperature of the cold is 30. Then the mixture has a temperature of what? 50 degrees Celsius. The next thing we want to look at now is the size, the mass. The mass. Who is times 2 of who? That's the next thing to look at. Who is times 2 of who? Is it the hot that is twice of the cold, or the cold is twice of the hot? Watch it. Hot is added to twice the amount of water. So you're adding hot to twice of his own original size. So if the hot is M, you're adding it to twice of his size, twice of the size of the water. So it is cold that is twice of what you have as hot. So having gotten this, you're not giving specific capacity here. So since they are still talking about the same thing, water is irrelevant, because whether you write specific capacity, they will still cancel out themselves. So let's write it as C equals to C. They're the same thing. So our principle, heat loss is equal to heat gained. Who is losing? Hot water is losing. MC change in theta equals to MC change in theta. Okay, and then the mass of this is what? M. The specific capacity is what? C. The change in temperature, what is changing? Since this is hot, mixture is 50. It means the hot is bigger than the 50. That's simple and clear. So big minus mixture equal to mass here on this side is 2m, because it's 2 times mass here. The C here is C. Change the temperature from 30 to 50. Who is bigger? 50 is bigger, obviously. So MC, cancel out MC. You are used to this teaching now. So we have T minus 50 equal to 50 minus 30, and you have 2 here. 2 brackets, 50 minus 30 is 20. So T minus 50 equal to 2 times this is 40. And then when you correct like terms, you have minus 50 going over. T is equals to 40 plus 50, which is 90 degrees Celsius. Obviously that is clear, because 90 is very, very high, very, very hot. So that is the hot temperature as 90 degrees Celsius. Let's see if we can take some more questions. Number 4. Please, I'd like you to follow along because this lecture is going to be a long lecture because of how important this topic is in your WAEC and in your JAM. Very, very important topic. So let's go to question number 4. It says a metal of mass 200 gram. First of all, write the question in short. A metal of mass 200 gram. So already we have gotten one parameter, which is what? Mass as what? 200 gram at a temperature. At what? Temperature. What's the temperature? 100 degree Celsius. At a temperature of 100 degrees Celsius is placed in is placed in 100 gram of water. You're getting the idea now. You have a metal that has a particular mass. You place it inside what? Water with another mass. So you see, already you're getting the idea that metal is the one losing heat, whereas the water is going to gain heat. So it replaces another water at what? At 25 degree Celsius. Now question, it says if the steady temperature, if mixture is 30 degrees Celsius, calculate specific heat capacity of what? Metal. We're looking for specific capacity of water of metal. Then we are given in our bracket there's SHC of water is 4,200 joules per kilogram per Kelvin. So in this case now there are two um, substance. One is metal, the other one is what? Water. So watch it very closely. It says the metal. So we have our metal in this case. Then we have our water in this case. Metal has a mass 200 gram, 200 gram at a particular temperature 100 degrees Celsius. It's placed in 100 gram of water. The water, the mass is 100 gram at what? A particular temperature 25 degrees Celsius. They said the mix is what? 30 degrees Celsius. It's very clear. This one, water that was 25 has gained, right? Metal that is 100 has lost completely. Specific capacity of water is 4,200 joules per kilogram per Kelvin. But you're asked to find the specific heat capacity of what? Metal. Unknown. Watch closely. Our principle remains the same. Heat loss is equal to what? Heat gained. Heat loss is equal to heat gain. Who is losing heat? The metal. Who is gaining heat? The water. The mass of the metal is 200 grams. Notice that it's in gram, it's in per kilogram. So let's convert this. You have 0.2 kg. By now you should be used to how we convert it. Divide by 1000. Then this will be 0.1 kg. So this is the mass. Mass of the metal is 0.2 times specific capacity unknown times change in temperature. It is changing from 100 to 30. That is 100 minus 30. The mass of the water 0.1 times specific capacity 4,200 times change the temperature is changing from 25 to 30. That is 30 minus 25. So you have 0.2 C times what? 70 equal to 0.1 times 4,200 times 5. So if we go quickly to multiply our values on the right hand side now, we have 0.1 times 4,200 times 5. You have 2,100 here. On this side, 70 times 0.2. 70 times 0.2 gives us 14. So 14c on this side. Then finally, as we progress further, we're going to divide by the coefficient, which is 2100 divided by 14. Please always press your calculator to be sure of what we are doing. No, not that when you get the exam hall, you are confused on how to use your calculator. When you divide now, you're going to have 150 joules per kilogram per Kelvin. That's what we got here. 2100 divided by 14 gives us 150 joules per kilogram per Kelvin. So that's it for this question. There are so many that will come up in our next class. So please follow along. Calorimetry is very, very important topic. It will come out in your exam always. Thank you.